Yes, can I go? Okay. Hi, welcome everybody. My name is Ulyana, I'm from FIRE, and I'm very happy to contribute to the LionWeb initiative. There was mentioned a couple of times that it's boring, but LionWeb might be boring for making standards, but actually making your own implementation of LionWeb is not boring. It can be very fun. Highly recommended. Yeah, you... I'm on. Does it work? Yeah. You heard so far about LionWeb a lot. The main mission of LionWeb is about connecting different language engineering tools, or in general, unlocking your tool for the rest of the community. And this work is about unlocking Rascal for the rest of the community. Who knows what Rascal is? How many people here? Oh, perfect. So Rascal comes from CWI Amsterdam. Usually the IT team is also present at Langdev. This time they're not here. I guess I'm a bit of proxy for them. Rascal is a language workbench from CWI. It exists for more than 15 years now. Started as a research tool. It also has a startup. You can use it for making your own domain-specific languages, but not only. It's also about code analysis and code-to-code transformations. So tasks like legacy code migration, something that Federico presented yesterday. Rascal is also used for this. So it's an interesting tool itself, but it's also an interesting challenge for LionWeb, because Rascal is a grammarware citizen. In Rascal, everything is a source code, like really text, and a language is a concrete syntax grammar. So everything is a concrete syntax, and from this point of view, it's pretty far away from LionWeb citizen, which is LionWeb, which is modelware citizen. And it's just a very interesting challenge to see that we can do it and whether LionWeb actually fits for such an exercise. So let's see, what's our challenge? In LionWeb, everything is a model. In Rascal, everything is a concrete syntax grammar. There's no model there. In LionWeb, when we introduce our language, it's about meta-model of a language. So when you define LionWeb language, it's meta-model. When we work with Rascal to express our meta-model, we can use algebraic data types. So for concrete syntax, we have grammars. For abstract syntax, we talk about algebraic data types. In LionWeb, everything is a node or object. In Rascal, everything is a mutable value. We have a lot of expressive means in LionWeb, like cross-referencing, inheritance, containments, interfaces, annotations, enumerations. Nothing like that in Rascal. There is no references. You can't. Everything is a pure parse or abstract syntax tree. What we have constructors for these algebraic data types, and they can be alternative, right? So how we would be used from BNF, from grammar. And these constructors can have parameters. And that's basically it. Yeah, looks like a challenge. Good news is that about 7 years ago, Thijs van der Storm did a research on bridging Rascal and Echo. And this is this GitHub repository. And so it means that it's possible. And that's what I used as an inspiration. And I will show you how it works. So I'll go directly into demo. I will take an MPS language, some simple expressions language. I will export it using LionWeb protocol into expression language in Rascal. I will create a corresponding abstract syntax in the Rascal side. There, I will wrap it with concrete syntax, because to use language, you need a concrete syntax. With this concrete syntax, I have a program that can be parsed, and then its AST can be exported back into MPS world. There I will change it and send it back, and we will see that the changes from this side will get propagated on the other side, if everything works well. So here everything that is orange is language agnostic. It's implemented, it's LionWeb implementation. It means that it can work for your language too. And everything that is blue is something I do manual custom for this particular language. My language, simple expressions language, an example, something that you would expect from an expressions. So we have a file that consists of statements. They can be computations, which is expressions. Expression can be binary or literal or reference to a variable that can be also defined in such a file. So an example of such a file in some concrete syntax is up there in the corner. Okay, let's see a demo. So first I go to MPS. And here I have this expressions language here. So something that, again, how many people here know MPS? Well, that's cool. Last time I had this talk, nobody knew it. So expressions file consists of statements. What we have here, we have a computation, which is an extend statement. Computation have expression. Expression is abstract. Yeah, something very basic that you would expect here. Binary expression consists of left and right operand. I guess nothing new here. Let's close all those. So now we take this language, expressions, and export into LionWeb JSON format. And I export into this file expressions language LionWeb, and I immediately put it as an input for my LionWeb Rascal. It doesn't matter where, it's just for you to have a reference where it goes. So I'm exporting a language. Let's see, yeah, it exported one language into this file. And now I go to the world of Rascal, which is in VS Code. So what we have here, I have some Rascal terminals, and first I will run the task that takes this JSON that we just generated in MPS. It will parse it, of course, as a JSON. It will create a LionWeb language in Rascal, and then generate a corresponding algebraic data type for this language. So let's see if it goes. Let's run it. Yeah. So what happened here, maybe just a note. So you can see here that the language got imported, and this is its tree. So we see a language. It has entities, it has classifiers, something that you could have heard in the previous talk, right? So classifiers, concepts, and there's expression file here. It's its name. It has certain containments. Containments has IDs, right? And what we generated from this is this file here. It's called language RSC, and it's got just generated. I have a proof of this with this line. It's a timestamp. It was now, but in a different time zone. And what you can see here is a Rascal definition of algebraic data types. So let's go into our expressions file. Expression file data type defined just like a data. It has a constructor. So expression file is a constructor, and constructor can have parameters. So you see we have a body, which is a list of statements. And for other parameters, I will talk later about special ID. So what is a statement? Statement is here. So statement can be either computation or variable definition. And what is computation? Okay, computation consists of actual expression. What is expression? Expression is either a literal or verbal reference or binary expression. So this is the way we define abstract syntax in Rascal. Now, when we have this abstract syntax, we need to have a concrete syntax next to it. And that's what I did manually. So I basically created a grammar with a keyword, using a syntax keyword in Rascal. So file consists of statements, but here you see they have a semicolon in between. Statement is either computational definition. Definition consists of identifier and expression. Yeah, concrete syntax grammar that wraps corresponds to this abstract syntax that we saw, and I also have a translators in between. when we have a concrete syntax, we can now create a model. Not this one model. In JSON, we want to have just a normal model, and this one. So this is my example model. Is it visible from the back, or shall I make it bigger? Yeah. So what I have here, I introduce a variable x with a value 5. I have two computations, 100 plus x and 10 minus 8, and I have an annotation. So like doc, everything after doc is annotation for the line of x is equal to 5. What we are going to do now, we are going to export this model into LionWeb from Rascal. So I will take this model from this file, this one, example expressions model, the one that you saw. I'll parse it and construct corresponding abstract syntax tree. And then using this language from a JSON that we had, I will generate a JSON example expressions file. I'm going to the corresponding terminal. They became super small. So now I run a task, this one. Everything is very scaled up. So it built 12 nodes in LionWeb and exported into JSON. And now I'll go back to MPS. So in MPS, I have this JSON to expression instance, which will take this JSON that we just generated and will import it here into MPS. And let's see. Let's do it once more because I'm not sure I removed this one. So I removed this one. Yep. Yeah, it appeared. This what you see here. It converted 12 nodes from JSON into MPS. And this is my example model, but already in MPS editor. I use a little bit different syntax here. You see, it's again. X is 5, 2 computations, and I have annotation there. And now we are going to change it. So I'll just do something, explode it a little bit with numbers. And let's try to add can I add an annotation here? Yeah, I want to add a documentation. And I'll add a new annotation to computation. Okay, now we are going to export it back to LionWeb. So we take expression instance to JSON. This is broken because it was removed and then created again. No problem. We'll remove it. It is here. Okay, and now let's run our export to JSON. Now it exported 13 nodes for those who don't see, because we added annotation, right? So extra node there. And we go back to Rascal. Now I'll open this one more task that I have. So now we import into Rascal. So we take this JSON file that we generated, example expressions file, and import it, construct a corresponding Rascal instance dynamically, and immediately print it into our model. So I'll open model here. I'll go to the corresponding terminal. Let's see what happens. Ta-da! Did you see? So we now have inflated values, something that we changed in MPS, and we have a new annotation, hello Langdev. We updated Rascal model from MPS. This is a demo. How does it all work? Because it's also interesting, right? Yeah. So how does it work? Let's start with inheritance. So inheritance is an important expression means that we use in our language engineering when we want to create a hierarchy in our language. So we express a relation, something is a, right? So we use inheritance to show like, okay, binary expression is an expression, right? Literal is an expression. In Rascal, you can do the same, but in a different way. And to do it in the same but in a different way, you need to revert this direction of this relation. So now we don't say binary expression is an expression, but we say expression is either binary expression or literal or verbal reference. So we express the same intention, but differently. What it means that in Rascal you'll get algebraic data type expression, where we have alternative constructors, right? So it can be literal or verbal reference or binary expression, and we inject the subclasses into a parent class. So expression is a parent class, and we inject different subclasses here. And we also, what we do, we delegate all the parameters of all children of the superclass to their subclasses, right? So now we have expression which has operation, but we delegate it to this binary expression. Okay, inheritance done. Now we have references. There are no references in Rascal, so you get like a pure tree. And for each new DSL, you need to create your own resolver using pattern matching or other mechanisms of Rascal. So what we have to do, we need to create identities for these constructs. And it sounds kind of the same as in the previous talk, right? So we inject identities to our data. So now we have IDs, and I implemented a library that provides you with a pointer that uses this ID for referencing, and then you can also do a resolution in the scope. Right? So now when you have a reference, you have a pointer, and this pointer resolution uses unique IDs that are injected in all data types. We need it anyway, because in LionWeb, everything should have an ID. Okay, good. Enumerations. Rascal doesn't have enumerations, but it's not really a big deal, because we have, again, alternative constructors. So we say, okay, binary operation is either plus or multiplication or minus. Looks very easy here. Annotations. LionWeb has annotations. Rascal doesn't. And Rascal had annotations, but they're deprecated. So now they recommend to use just keyword parameters to introduce annotations, which means that we have to revert this relationship again. So now not documentation annotates a statement, but statement has a documentation. Which means that we introduce a list of documentation in our statement. And statement, because it can be either computation or variable definition. So now all of the subclasses of statement also have this documentation injected into them. We kind of explode a bit our structure. So, looks like we ticked all the boxes. I showed you we can create a corresponding language in Rascal from LionWeb, and we can transfer data on the M1 level in between these language workbenches. All the code is available on GitHub. You can try it out if you want, if you're not scared of Rascal. Looks good, right? But that's not all, of course. So there are some challenges left. And first challenge what I observed during this work is that, okay, we now covered expression means of our language workbenches of LionWeb, but it's not only about expressive means. It's also about pragmatics, right? So our tools also have pragmatics in the same way as languages that we make have pragmatics. For example, what about modularity of languages, right? So when we or extension mechanism that we can use there, all right? For example, what I encountered in the test suite of LionWeb, what you can do in MPS, you create a kind of abstract language that uses some interface in it, and then we can extend or kind of concretize this language by creating a specialization of this interface in another module, and then use it there, right? So we build a hierarchy of languages also. Pragmatical approach, we just saw that in our Rascal transformation, this specialization arrow should go backwards. But that means that also our extension mechanism for the whole language goes backwards. Not maybe something that we really want. So how to map pragmatics from one tool to another here? Another challenge, also mentioned a lot this morning, Delta protocol, right? How do we, so what you saw now was a bulk protocol. We just send the whole model in between in both directions. But what if we want to upgrade our Rascal program gradually? And what if you have a layout there, some comments that are not in the parse tree, that are in the parse tree, but not in the abstract syntax tree that we used to send in between. And also from point of view of researchers, so if I talk with CWI team, they say it's very hard problem to solve, Delta protocol for Rascal. And you saw one direction, right? I took LionWeb language, sent it into Rascal, but I didn't do backwards. So what if we have a Rascal language, grammar? Can we extract a LionWeb language out of this and import it in MPS, for example? I don't know, maybe we want it. So how to do that? To conclude, for what I took out from this experiment, LionWeb is can be a very powerful mechanism. I envision it as some kind of tunnel that we dig in between our tools, but this tunnel has certain widths. So I wouldn't take just a DSL and push it through, because then we can get stuck there. What I would do is to adjust it a bit first to send it through LionWeb. So, like you saw, on the Rascal side, I needed to create a concrete syntax that would fit it into my Rascal world, while LionWeb-based generated AST was quite clocked and big. And on the same way, on the other way side, so maybe if your tool doesn't fit totally to the LionWeb expressive means, you might need to change your language. Knowing pragmatics of your tool and knowing specifics of your language, we might need to do it for every language again. But if we implement these transformations there on M2, we'll get M1 for free. And that's where the power is, I think, because then you can actually move your models in between your tools. Thank you.
So we have some time for some questions. Are there questions?
Question gets a vowel.
Oh yeah, that will solve it, I guess. Are there now questions? Now we get them questions. Well, then first start with your first question, Jos.
No, I don't have any questions.
But you still want to tell?
No.
You said that it was a very hard problem or a challenge at least, to get the Delta protocol. Well, at least you there's an open challenge.
Yeah.
Do you have some ideas how to nail that one, or going to nail that one?
I have seen it working for custom-made examples, but like research level, right? So they take it as a publication and they make a small DSL. For one concrete DSL, they can do it. So I guess you need to store all this location information and do smart think about deltas. So something related to the talk of Pedro this morning, right? So how you solve this the sequence of deltas, what means what. I don't know. It might be really fun. I think it's the whole PhD work, honestly. So if you have any candidate and want to do fun stuff, this might be a way.
Okay, cool. Question, Pedro.
I have one about use cases for this. I see the experiment.
Yeah.
Let's suppose that we want to get this to real life. For example, I imagine maybe connecting the model from Federico for migration.
Yeah.
And then moving some part to Rascal, just because Rascal is good for some kind of verification or something like that.
Mm-hmm.
What kind of use cases you feel that this would be a good bridge to use?
Yeah, so Rascal is being used for also this legacy code migration. As far as I know, I heard COBOL mentioned by them a lot. And then so what we want to do, we want to connect tools and things that we already implemented in one tool but not available in another one, right? So what you could imagine, I worked in model-based testing before. You can imagine about on generating, for example, model-based testing input for the tool that does model-based testing for you, to compare semantically legacy code with your new version of a code. But you get it only like in the tool, let's say, Fire implements it in MPS. And now we want to connect the results of a Rascal extraction of a model to this one, right? So I also have seen a lot of work in formal methods world where they create amazing things, but for very concrete tool, for example, for Eclipse. How would you be able to connect? And they're useful. You can imagine use cases where you can sell it to your clients, but they are there, and you don't want to re-implement it for your tool. So for me, this is a way.
So you can tell.
No,
Oh, you know. Yes.
Yes, Alessio was telling about how they put extra information in LionWeb, line numbers and things like that, so they can work with grammars and line at the same time. Are there any ideas from his presentation that could help solve you some of those problems?
Who had sorry, whose name?
Presentation
Before me, yeah.
There seem to be a lot of similarities.
Yes, true. I need to see a concrete thing so to answer this question. But indeed, I wasn't realizing that they also work with ISTs. Yes. Yeah. Anna?
Were you familiar with LionWeb before you started this exercise? Did you know the details of it?
Yeah, I have Nico on the call, right? So.
Yeah, well, okay, sure. Because I was wondering if knowing what you know now after this exercise, you would do the transformation differently.
Transformation differently? No, I followed actually transformation. I followed in the steps of Thijs. So certain things, of course, are very different in eco. By the way, eco is also different from LionWeb, so the things there wouldn't work. So I had to do it differently. But yeah, I was in a short call with Thijs and a short call with Nico, and I think one of the things that we want to do different is annotations, but it's also a question to Rascal how they implement it. It's a bit clogged now, the resulting structure.
Cool. That's fine. Oh, that.
Yeah, perhaps it's more a question for the LionWeb people, but you can now make a transformation from the M2 meta model of MPS or LionWeb basically to Rascal, but the other way around is more difficult, I think.
Yeah.
And one of the things is that if you have a grammar, then you can have several alternatives, but an alternative can also be used in more than one. I don't know. So does LionWeb support multiple inheritance, basically?
Yeah, LionWeb supports interfaces and multiple specialization of interfaces, but only on the classifier, on the concepts level, only one extension is possible.
So there is a one-to-one mapping possible between grammars and the LionWeb mapping?
Grammars don't have interfaces.
No, okay, but you could use interfaces to implement some kind of things that you can do in grammars.
Yeah, maybe so. For me, I would really go this way. I would take a grammar and create a instantiate LionWeb in Rascal. So I have a LionWeb structure now as a meta language in Rascal.
You still need to have a transformation.
Yes,
between the two, so
you need to have a transformation. Yeah, yeah. I'm afraid that if you do it on a generic level, you will get something unusable.
Okay, so you say you do manual.
No, not main. It depends. But somewhere you have to do manual work, right? Now it will be on M2.
This is